Assalamualaikum and very good day. My name is Mohamad Amirul Fadhli. I'm the representative of Group Hello World. Would like to present about our project, which is Elevator Simulation System. And start with me. My name is Amirul Fadhli and my ID matrix is HA18014. Akid Shazri, HA18003. Erichin, HA18029. And Mokhzani bin Abu Bakar, HA18013. So, the objective of this project is to the lift should have at least one lift and the total number of level is 10. Inside the lift should have inside and outside buttons to go to the desired level. And passengers can press any level that they want simultaneously for both inside and outside buttons. And we should design our own pickup solution. And lastly, our project is creative and user friendly. Now, I would like to present about our GUI layout. So, at the start, in our GUI layout should have will have a lift monitoring diagram, and the second one is floor controlling inside each lift, and also at the middle of at the top, we'll have a global controls, and also at the left side we have button moving up and down at the outside of the lift. As you can see at the bottom left, we can see that there is the lift movement diagram. And finally, at the middle of at the bottom of the middle, we can see that it is our final layout. Now we move on to use case diagram.
In our report, we're using two categories of UML. One is structural diagram and another is behavioral diagram. A few examples of the behavioral diagram we are using are use case diagram, sequence diagram, and activity diagram. As we can see, the use case diagram here is simply show that the relation or interaction between the passenger and technician for the elevator control system. Inside the column, we know that what can the passenger and technician do. For example, for the passenger, they can call the elevator select flow. However, for the technician, they can access to call the elevator select flow, reset elevator, control all the elevator to top and bottom. Next. Okay, this is the sequence diagram for the elevator. As we can see the diagram, there are 7 objects in the diagram, which are the passenger, elevator call button, elevator control panel, elevator system, LCD display, LCD output display, elevator, and door. So first, when the passenger press the call button outside the lift at the second floor, the elevator system will receive the data. At the same time, the second floor button will light up. The data will update to the LCD output display, then give a feedback to the elevator system and move the elevator to second floor. When the lift reach second floor, it will inform the elevator system and the lift will stop. Next, if the call button outside the lift will stop illuminate. After that, the elevator door will open and close. After the passenger get inside the lift and press the floor number 8 at the elevator control panel, it will update to the elevator system. At the same time, the control panel button floor number 8 will light up. Then it will update the LCD output display and give a feedback to the elevator system. Next, it will move the elevator to go upward until the lift reach the floor number 8 and then stop. The control panel button inside the lift will stop illuminate. After that, the elevator door will open and then close again. Next slide.
Hello. Okay. Right now, I would like to explain about our class diagram. We mainly have three classes, which is Lift Simulator as our super class, and then Lift Controller and Lift as our class. For our super class, we name it as a Lift Simulator, which is we have all the control there, all the global control button, and then also the Lift Controller, which is also relation to the function in the lift simulator and then the lift itself. As you can see that the superclass is lift simulator and it is associate one-to-one element with the lift controller, but one-to-many as with the lift class because we have 1 to 3 lift in our program. And then the lift and the lift controller is also many to one associate because of the we have so many lift but we have only one controller. And then this is the relation of our class diagram.
Now I will be presenting about the activity diagram. First, we have activity diagram for person. The first step is to move towards the floor button, which is the button outside our lift. And then they have an option. They have two options. If the door already open, they can wait for the passenger to exit the elevator. If not, they can press the floor button and wait for the elevator to arrive. After that, they get into the elevator and then press elevator button to their desired floor. After that, just wait for the door to open and exit the elevator. Next, next we have um, elevator for activity diagram for elevator control. First, the elevator will be at idle state. Then, any button is pressed, whether it is the floor button or elevator button. It will look first if the priority is to go up or not. If not, the elevator will be moving down. If yes, it will go upwards. If you look at the left side, it's an activity for the lift to moving up. After it detects the priority is to go up, it will start moving up. It will be keep moving until it reach the requested flow. If there is any button pressed again, same scenario will happen. It will check first for whether it is the priorities to go up or not. If yes, this process at the right side will be just repeating itself. If the request go to the lower floor, it will proceed to the activity. The activities to moving downwards. If there is no request, it will just keep idle at the current flow. At the right side, it's also the same as A, but the direction is to go downwards. Same process in both, just different direction, which is going downwards. Next, for our global control, we have four buttons: reset button, reset all, moving all to bottom, and moving all to top. Uh, if First, we have the reset button. If the reset button is pressed, this function will be called. This private void underscore reset button. If the reset button, it will affect all the buttons for the lift, so it can't be pressed anymore as it will go to their original state. No matter which floor the elevator is or where the direction it is heading, it will be reset to the original position once reset button has been pressed. Besides, we also have reset all to top, and all to bottom button for our elevator. These three have quite a similar program. The only difference is the action it will make, which for all to bottom, it will take all our lift to bottom, which is ground floor. To all to top will take all our lift to uh, 9th floor, and reset all will stop the elevator at the last requested floor. As an example, when we press all to top button, this function will be called private void button to top. We have to reset all button so that all the elevator can't be disturbed anymore. Means no matter how hard or frequently someone press the floor button, it is no use once all once either of this button has been pressed. It will go to the original state and the lift controller will take all the elevator to the top floor, bottom floor, or at the last requested floor. And F2log will be displaying the current state of our elevator. I think that's it for our global control. I will pass to my teammate Eric.
Okay. From the left hand side, there's a LCD display output program. The program is all about to update, label, and convert all the text of the log into the string inside the label so that the number can show and update in the label. From the right hand side, there is the call button program. First, we can see the public void functions to send leaf of send leaf. The application of send leaf function is to add a new destination to the leaf. For example, when a passenger press button, it will update the new destination to the leaf in send leaf function. However, the problem is which elevator will be chosen to pick the passenger. To choose the lift, we should use the private get nearest lift function. Inside the function, we had add the if else statement in for loop. If, for example, if the integer of the current floor function is same as the destination floor, it will return to -1, means that the lift is already at the same floor of the button click. If there is no lift on that floor as a destination, for example, there's no lift on second floor when the second floor button was pressed. Therefore, we set a priority of nearest lift to pick the passenger. In addition, if there is 3 lifts at the same floor, we will set a random number for the lift to pick the passenger. Lastly, if the lift have the same distance or same nearest point, for example, one of the lift at the first floor and another for at the 5th floor and 9th floor. So we will set a random number for the elevator to pick the passenger. Next slide.
So now we move to the next floor sequence program. So starting at the public void move next, we will give integer for the next floor. Counter and change. If the current direction is moving down, the integer for counter and change will change to -1, while the opposite direction is up. This is mean that the direction of the leaf will be moving down and not going up. Else if the current direction is moving up or the current direction is idle, counter and change will change to +1, then the opposite direction is down. So that's mean that even if one leaf is idle, the leaf will be scanning up. In the following process, the integer next floor will still -1, which means while the programming is simulating, the leaf will scan or check if there are any floor that need operating in the direction specified, whether it is going down or up in either position. Next, moving on to the cache, which means a program catches an exception with an exception handler at the place in the program where you want to handle the problem. The cache keyword indicates the catching of an exception, and for the index out of range exception class means the exception that is thrown when attempt is made to access an element of an array or collection with an index that is outside its bounds. This part means if the current direction it has nothing to do or does not have any services or operation, the leaf will change its direction and start to do for move next, or else if the current direction or opposite operation does not have any service or task or operation, it will go idle and go break. And lastly, if the next flow is inequality to -1, we will start to service based on the needs of the leaf.
Okay. So first I would like to explain about the leaf monitoring diagram. For the leaf monitoring diagram, we don't use the blinking or the every box we light up. We use we want to have the smooth transition or smooth animation. So we move the floor or the picture box using the coordinate y-axis coordinate. Okay. As you can see, we have 10 floor and then we have 10 y coordinate, each from G to the ninth floor. And we have set our ideal position or the starting position of each of our lift is two at the ground floor and then one at the ninth floor. And then this monitoring diagram also uh, will affect all the lift, not only the although from the program we can see that we have only y axis for one lift. Actually, we contribute it with the array. So each lift will have the same coordinate. Okay. So next is for the timer and DQ. For the timer and DQ, we use the tick property or date time property. Okay. Uh, so every time the lift moves is like ticking in 1 second. Okay. So when the floor is equal to the destination floor, okay, the current floor is equal to the destination floor, it will stop, and then the timer to start it working or operation again will start also. Okay, so that is how we use the timer. And then the DQ also, when the our function DT move dot stop is start, then that is the time where we send to the controller the lift is DQ for that call or the floor destination. Okay, and then it will start again to find a new queue for the lift. Okay.
Okay. Now, we start our demonstration program. So now I will show the simulation program. So as you can see here, the lift 1 is at the ground floor, lift 2 is also at the ground floor, while the lift 3 at the ninth floor. So if I press the button floor 2, floor 7, floor 8, so this is the button inside the lift. So it will go accordingly to their request or their operation. So if I press the button at the left side, which is the up and down button, if I press 4, the nearest lift will go to the requested floor. If I press floor 6, and the nearest lift also will go to the location. If I press floor 1, so the lift 1 will go to the floor 1 because because the lift 1 is the nearest. So if I press many times as I want, so it's already lift 6, lift 6, lift 5, lift 4, lift 3. So if I press 5, 4, so right now they are moving accordingly to the requested button. So if I press floor 7, any lift will go to the floor 7. So right now lift 3 will go to the lift 7, because in our program we put randomly number for the floor to go to the requested floor, for the lift to go to the requested floor, floor 6. Because when I press floor 6, the lift 1 will go to the floor 6 because I press the floor 6 inside the lift 1. Floor 4, floor 6. So right now, if I press floor 8 and also floor 6, I will go break at the floor 6 first, and then go to the requested floor, which is floor 8. That's all for the simulation program or demonstration. Now, I will pass to the Mohzani for conclusion.
So, as a conclusion, simulation is a way of developing an application or design simulating the real world, the way which helps in clarifying the real idea. The reason for using simulation may be for literature, cost, time, or safety reasons. From this project, we learn how to develop an elevator system by using C# GUI programming. We successfully developed an elevator program by fulfilling the requirements that were needed for this elevator. In order to make it easy to explain, we also make few diagrams of how our system will be working. I think that's all from our group. Thank you.